Hi everyone, welcome to Cola Teaches Math. So here's my Unit 7 review on differential equations. The topics that you need to know are matching slope fields, particular solutions, Euler's method for BC, and logistic differential equations for BC. So there is not going to be matching slope fields. There's not going to be sketching slope fields, but there could be matching slope fields on the multiple choice. So what I like to teach my kids is I say choose coordinates from each quadrant, calculate the slope. Like, look at the quadrant. Okay, so check it out. Say I have my quadrants right here. And at the point 1, 1, my slope is 1, -1. So look at these. These are all my slopes. I'm just making something up. So what you're going to do is you're going to go to each answer choice. Let's pick some nicer colors here. Let's do purple. You're going to go to each answer choice and say, okay, at the point 1, 1, my slope is positive. And you're going to plug 1, 1 into every answer choice and confirm you get a positive slope. Do the same thing here. At the point -1, 1, it's a negative slope. So you're going to plug -1, 1 into every answer choice, make sure you get a negative slope, and so forth. And that can help you eliminate and choose and match the slope field. All right, particular solution. There's two types you need to know: exponential differential equations and just these other differential equations here. So you can watch me solve this one. So K is the proportionality constant. They tell us dy dx is equal to ky. So first thing I'm going to do is I'm going to cross multiply so you guys can see my algebra. And I'm going to get dy equals ky dx. I would suggest you keep the k with the dx, so now I'm going to divide everything by y. And we're going to get dy over y equals k dx. We're going to integrate both sides, and that's the ln of y equals kx plus c. You don't need to show this, but I will. This is how I like to teach it. E both sides right now, and you would get y equals e to the kx plus c. Split it up, e to the kx, e to the c. And instead of writing e to the c, you are going to call this big C. So you have y equals c e to the kx. You can jump from the purple to the purple on the AP exam. Now, c is always going to be the zero initial condition. So when x is 0, y is 2, that means c is going to be 2. We now need to replace c with 2. Okay, so we're going to have y equals 2 e to the kx. We're going to use our other initial condition, y of 3 equals 5, to solve for k. So we're going to have 5 equals 2e to the 3k. Isolate the e. 5/2 equals e to the 3k. ln both sides. ln of 5/2 equals 3k. ln of e to the anything is anything. And divide out the 3. So then k comes out to be 1/3 ln of 5/2. Once again, we now need to come up here and replace k. And then we will have our particular solution. Y equals c is 2. E to the k is 1/3 ln of 5/2 x. That's the particular solution. All right, now up here, this one's a little bit more involved. I think I took this from an AP exam. So step 1, cross multiply. I'll do it in a different color. These are ugly colors. Let's do something bright, hot pink. So let's cross multiply. We're going to get rad 1 minus y dy equals x dx. We're going to u sub this. U is 1 minus y. Du is negative dy. Dy is negative du. We're going to plug in for what I underlined, and you're going to get u to the 1/2 negative du, which is negative u to the 1/2 du. Add 1 to the power, divide by the new power, and then plug back in for u. So we're going to get negative 2/3 u, what is u? 1 minus y to the 3/2. Okie dokie equals, now when we integrate the other side, we just get x squared over 2 plus c. This is the general solution. I didn't give you any initial conditions, but I can. Let's do, why don't we make one up that says y of 1 equals 0. So I'm going to replace y with 0. And x with 1. Okay, when I solve this side, 1 to the 3 halves is 1. 1 to anything is just 1. So this side's just going to become negative 2/3 equals 1/2 plus c. Take away 1/2 from both sides. And you are going to get negative 2/3 minus 1/2. Negative 7/6. Plug it back in, negative 2/3, 1 minus y to the 3 halves equals x squared over 2 minus 7/6. And now we would have to get y alone, so you can watch how I'm going to do that. I am going to multiply both sides by the reciprocal. I am going to have to finish it over here, and I'll do a different color so it stands out. So I am going to multiply both sides by negative 3 halves to get rid of the fraction. And we're going to be left with 1 minus y to the 3 halves equals x squared over 2 minus 7/6 times negative 3 halves. To get rid of the power of 3 halves, I'm going to raise both sides to the 2/3 power. So let's go ahead and do that. And you're going to be left with 1 minus y equals x squared over 2 minus 7/6 to the negative 3 halves to the 2/3 power. And then I'm going to rearrange it. I'm going to move the y to one side and move everything over to the other. So your final answer is going to be y equals 1 minus this bracket, x squared over 2 minus 7/6 times negative 3 halves to the 2/3 power. And that's my particular solution. All right, next, you have to be able to do Euler's method. I posted a separate video on this. Just remember, delta x is your step size. I'm just going to give you an overview. Step size, sometimes they tell it to you. Sometimes they tell you how many steps. You can figure out by doing b minus a over n, where n is number of steps. And then a and b are the starting and ending points. So x and y is the initial condition that you're given. dy dx is you're plugging the initial condition into the derivative. To get delta y, you're doing delta x times dy dx. So whatever you get in this column times this column. So delta y is delta x dy dx. And x plus delta x is you're just going to take the original point, the original x, add delta x to it, the original y, add delta y to it. You can watch my other video on Euler's method on my YouTube or my TikTok. And last but not least, logistic differential equations. What do you guys need to know for the AP? So you need to know logistic. All right, for logistic differential equations, what you guys need to know is we have a carrying capacity here, and the limit as t approaches infinity is going to be the carrying capacity, which we're going to call L. L is the carrying capacity. Okay, we are growing the fastest. Growing fastest at L divided by 2, which is the point of inflection. So we're growing the fastest right here, L over 2, which is your point of inflection. More concave up here than concave down here. And last but not least, you're going to want to be able to spot a differential equation, a logistic differential equation. So dy dt equals ky 1 minus y over L, where L is the carrying capacity. There are a few other forms out there that you can definitely memorize, but I just find this one to be the easiest and the most common one. Okay?